Okay. All right. So here is your chapter 2, which is on measurements. Now, I need to ask you guys, in what context do you guys do the measurements?
When I feel like interested in measuring something, I just try to measure it and do calculations on it.
Very good. So one thing that tells me is that whenever you're doing measurements, you are using some kind of a measuring device, right? Some kind of apparatus. Okay, that could be something as simple as a measuring tape, or it could be like a clock, or even a stop clock, or a stopwatch, or it could be a thermometer. You're measuring the temperature, right? Or it could be like kind of like a container in which you read like how much of the water is there, in that, or liquid is present in a container, and there are markings on that, like a measuring cup. So there is, so for the measurements, you actually read the numbers, right? You take the reading. So that's the measurement. Calculations is different. Calculations is when you are actually, performing the computation. So mathematical computation, and which is based on the rules and the formulas and, whatever the rules are for the chem. Just now we discussed that. So that's one thing. Now, here's the thing. Whenever you're doing measurements, there is a chance that you are going to introduce some kind of ambiguity. Ambiguity means that there is going to be, maybe there are chances of some error. So there is a concept of accuracy and there is a concept of precision. Okay, now, normally, okay, normally in the labs, students, because you guys are learning, when we talk about accuracy, that means that the professors know the true value. So when we talk about accuracy, we are looking at the true values. The true values are the values that are already known. They are known. Like, for example, because in labs, you're learning, right, things. So maybe you're measuring the density of some device or something, some sub-object, and that density is already known. The professor already knows the density of that object, or the density of that object is made up of the material that is already listed somewhere on Google, somewhere, searches, right? So this known quantity. When you take your readings, your measurements, generally you do them in 2-3 trials in the labs. And so those trials, you may be making a mistake, okay? And what happens is that every time you do a trial, then maybe all your answers are coming in the same range, right? The trial, the results, when the results in same range, right, close to whatever the answer keeps coming the same or in the similar range, then that means that your data is precise. This means that you're gathering a data that is precise. But if you are, it may be accurate, it may not be accurate. If it is accurate, that means it is going to be close to the true value. Okay. But if it is not accurate, that means that, and every time you keep getting the same results, that means somewhere there is some error in the steps. You're making some mistake continuously in the steps. So there could be error in the steps. There could be error in the way you are taking the reading, okay, or there could be some other type of errors beyond your control. Okay, so uncontrollable errors also happen. Like maybe the person who made the solutions made a mistake there, or a person who in the labs, maybe there was some error in making the experiments. We provide, we have lab assistants who make the labs ready for the students. So maybe there was an error there. They put the wrong solution. So you're now reading off of the wrong. So those things. So there are some uncontrollable errors also. Okay, so So those things when we are doing now, whenever we are doing these, so these numbers, whenever we are doing these readings, we are always using numbers. Always, you're reading these numbers. These numbers have no values unless you put the unit. Okay, now what kind of units? For example, when you're taking the data on mass, so what kind of units are there for the mass? What kind of unit?
Grams and all the other associated numbers. I mean, units.
Grams and kilograms, milligrams, micrograms, right? And what else for the mass?
Tons.
Tons, very good. And tons,
Pounds.
good. And one more.
Liters, is that a thing? I don't know. I'm guessing here.
The liters are, 1 minute.
Is that the wrong one?
No, 1 minute.
Stones.
Liters is in volumes. Yeah, so it's okay. It's okay.
Stones. Is that what you're looking for?
I'm looking for.
We said ounces already.
Did you say stones?
Stone.
Yeah, like it's British, I think.
Yeah, older one. Yeah, an ounce. Ounce also. Ounce.
We already said that.
Yeah.
Oh, you
Okay,
did?
what about volume? How much space a substance? So liters is one thing.
Yeah.
Liters.
Liters is one thing. Milliliters, microliters, deciliters. What else? For the volume.
What is that after mg? I'm sorry.
Grams.
Oh, okay.
Milligrams. Okay. So quarts, quarts, quarts. That is also a unit for
Gallons.
gallons. Very good. And pints.
Cups.
Very good. Pints. Okay. So these. Next is, let us say one more. Let's do it for the length. Length.
Meters.
Very good. And
Centimeters.
Yards. Feet.
Feet.
Miles.
Miles,
Kilometers.
kilometers, and
Inches. Yards.
yards. Very good. And one more.
Nanometers.
Feet or foot or feet. Okay. All right. So these are just general ones. And let's do one for temperature.
Kelvin.
Very good.
Fahrenheit.
Fahrenheit and
Celsius.
degree Celsius, degree Fahrenheit, and Kelvin. Yeah, I don't know why for Kelvin we don't put degree sign, but for the other two we do. But that's what it is. Okay, anyways. So now there are two types of, like the prefixes, first of all this micro and milli and kilo and all this, what does it mean? Okay, so now we are going to look at here, these prefixes. Let's just do this here, prefixes, which first of all tell how big or how small a substance is. So let us say we put the prefixes that decrease in size and the prefixes that increase in size. So for example, let us start with the word, let's say 1000. So kilo. Kilo is expressed as K and it is 10 to the power 3. I'm going to just put it like that, 10 to the power 3. So if you have like meters, it will become kilometers. If you have grams, it can be used as kilograms. So like kilograms is kg, kilometers is km. So that would always mean like 1000 meters is equal to, 1000 meters is equal to 1 kilometer. That's what it means. Okay, so next is lower than that. Lower than that is, let's say deci. Deci is, I'm going to just put it here. Where did I put? 1 minute. Okay, opposite of kilo. Opposite of kilo is milli. And milli is small m. And that is 10 to the power negative 3. Okay, so like millimeters, right? Milliliters, that means like a smaller unit. Okay, next is, for example, you have mega. We're just looking at the big ones now. Mega, the opposite, the mega means like mega millions, like m, and m stands for like 10 to the power 6. Okay, so like I said, mega millions. And the opposite of mega is micro. Opposite of mega is micro, and micro is represented as like this, and this is 10 to the power minus 6. So this is like micrograms, like micro liters, like really small amount, like little drops if you put. Okay, next is, let's say, giga. So like gigabytes. Gigabytes is represented as capital G, and this is 10 to the power 9. So giga, like generally, gigabytes in that case, I'm going to just write down here, or gigahertz, gigabytes, or in the terms of this is gigahertz. Okay, next, opposite of giga is what? Opposite of giga is? Opposite of giga, nano. Small n, and this is 10 to the power minus 9. So like nanomolar. So this is like for drug discovery, we use this. Nanomolar means like really small, like molar is also unit. This is also a unit. So that's the amount of like the concentration, or the amount, very small amount of medicine or small amount of drug. Okay, next is the pico. Pico is also very small. Pico is shown as small p, and this is 10 to the power minus 12. And once again, this is picomolar, like very small amount, picomolar, like really tiny bit of medicine that is needed to bring the desired therapeutic effect in the body. So when we do the testing of that medicine on animal models, so this is like how we come to know. Okay, then comes the opposite of this guy is tera. Opposite of this is tera, and tera is 10 to the power, tera is capital T, like again, terabytes, 12, and this is again terabytes, TB, and so forth. Okay, and then there is this thing, femto and peta, that's like even more. But let's look at the other smaller ones. Milli, above milli is the centi. Okay, the centi is like really small, and then deci is even like, is also very small. So centi, deci is like D, that's why I said deciliters, like really small, and you use this as again in biology labs. And centi is like centimeters and so forth. So centi is just C. Deci is 10 to the power minus 1, and centi is 10 to the power minus 2. So centimeters, okay, or centigrams balance. So it's going to be 2 places after the decimal. So this means 0.01. So if you see these 2 places after the decimal on a machine, that means it's a centigram balance. If you see 3 places in a machine, then it is a milligram balance. And if you just see 1 place after the machine, after the decimal, that means it's a decigram balance. Okay, so that's also the sensitivity of the balance. So with that said, now we also have these equalities, and then we are looking at the conversion factors. So these prefixes are just used very generally, right? Generally, and they can apply to any of the units. So we looked at, these are the units. Besides that, you can just add on here. There are units that are used for like time. Time is, for example, seconds, right? Minutes, hours, also like days, like months. So these time, like, you're going to look at the half-life of objects. So half-life of medicines, half-life of radioactive substances, that is measured in time, right? And then also other types of units are also like, for example, density. So for the density, it is mass over volume. Okay, mass over volume means grams per milliliter or grams per centimeter cube. So when it is milliliters, it is liquids. We are measuring the density of a liquid. But when it's centimeter cube, it is a solid. Okay, so this is how you do these units. Then the prefixes tell us whether it is a small or whether it's a big unit. Okay, so I'm going to just put it here, this line. So all the small ones start from here. And the big ones are from the top, right? So just put this here. And then these are the small ones. Okay, so keep these sets two different. Now let's look at the equalities. Now equalities are these, see, here's the thing. Why, first of all, what was the need for equalities? In the past days, long time back, there used to be barter system, right? And barter system is where people would just trade. People would just trade things, one is giving something and the other is giving something and just trading equally. But that was based on the need and want. But as the time changed, people become more like quantitative, more measurements got more value. So in other words, there should have been equal value. Now, let's say in the past, people would measure their fields, right? And they would measure their fields based on the feet. So whosoever had a bigger field obviously got a bigger field, agricultural field. And the ones who had smaller feet, if the king asked them to measure, then either they would take very long or they wouldn't get that much of the land. So that was again not equal, right? It wasn't like you're more privileged and you're not. No, that's not the case. So we wanted to have equality. Besides that, every country was using their own measurement system. So then on a universal scale, if when, things became more globalized, they said, okay, no, we guys need to have some, equality on the value of things. So that's where it came. So here's the thing. There is one is the SI unit, which is used all over the world. And then there is a US system, which is called a US system. And then there is conversions. So what does this mean? Now, SI systems are like, for example, in the case of length, for example, if you're measuring something so in that case, the length would be like 1 kilometer is going to be equal to 1,000 meters. So that is the SI system. Okay, similarly, one centimeter or let's say 1 meter is equal to 1,000 millimeters. So that is simple SI system. Okay, but the US system uses something else. They use like feet. So 1 feet is equal to 12 inches. Okay, and then or they use like 1 yard is equal to 3 feet. Okay, or 1 mile is equal to, so we use miles here. 1 mile is equal to 5,280 feet. Okay, and then comes the conversion. Now we need to convert them in order to stabilize these two. So how do we do that? So they've developed this. So in other words, like 2.54 centimeters is equal to 1 inch. Okay, 1 inch is equal to, no, sorry, one meter. Is it 1 meter or 1 meter is 39.4 inches. Okay, and then similarly 1 kilometer is some miles and one. So these are just the basic conversions of the two systems. Similarly, if you have a volume, and I'm going to just take a few examples. So for example, 1 liter, commonly you are going to use in this course, 1 liter is equal to 1,000 milliliters. So this is the SI unit. Now in the US system, we use like, for example, 1 quart is equal to 2 pints. Okay, 1 gallon is equal to 4 quarts. Okay, so how do we equalize this? So 1 liter is equal to 1.06 quarts. So these have now been like universally applied and used. So one pint is equal to 473 milliliters. Okay, so these are the basic ones. Let's say the mass also. 1 kilogram is equal to 1,000 grams. So this is again the metric system, the SI system, more universal. But in US, 1 pound is equal to 16 ounce. So this is the system we use. But how do we equalize with the SI system now? So 1 kilogram becomes equal to, which is coming from the SI system, and this becomes 2.20 pounds. Okay, or like, so same as the case, 454 pounds, no, 454 grams is equal to 1 pound. Okay, so these are again the equalities. Now, fine, we got these two things under control, that we equalized the units in all these different parts of the world, right? 1 minute. Now comes the concept of conversion factors. Conversion factors. And conversion factors. Now, conversion factors, see, in British system, it's a different thing, but I think American system, this one is much better, easier. It's easier. It's really, it is easier. So now let's look at it this way. We have 1 kilogram. 1 kilogram is equal to 2.20 pounds. Okay. So what are the conversion factors? Conversion factors are 1 kilogram over 2.20 pounds. The other conversion factor is 2.20 pounds over 1 kilogram. Okay. Now, why these two? The driving force is, what unit do you want? That want stays in the numerator. In a fraction, it stays in the numerator. And the one that you want to remove, the unit that you want to remove or you want to convert from, that stays in the bottom in the denominator. Okay, so this is one thing. Next is, if there are problems, so this is one type. This is one type. Let's see, put it this way. So this is one type. Second type is where they are stated as kilometers per hour. Like, for example, the units that are coming from the, like a formula, or like, for example, this one, that 85 kilometers per hour. How can you convert this into equality? So this means 1 hour is equal to 85 kilometers. And really, because it's equality, it doesn't matter. You can also write down 85 kilometers is equal to 1 hour. This is another way of breaking up this type of, unit. Okay. So this is also one unit and this is another unit. So these two units have been equalized like this. But if you have it like in this formula form, then you convert it like that. And now, what are the conversion factors? 85 kilometers over 1 hour, or 1 hour over 85 kilometers. All right. And again, if you want to find some unknown hour, then you use this unit. If you want to find some unknown kilometers, then you're going to use this unit. So this is one thing. Another thing is from a sentence. Now the sentence is saying one tablet of vitamin C contains, so this is the full-fledged sentence, contains 50 milligrams of vitamin C. Okay, so this is the sentence. So in this sentence, this whole sentence, how do you convert that? So first thing is, one tablet means one tablet. contains 500 vitamin C means is equal to 500 milligrams vitamin C. Okay. And now you can convert the conversion factor. 1 tablet over 500 milligrams vitamin C, or 500 milligrams vitamin C over 1 tablet. Okay. So this is one way. Next thing is a very interesting thing, and that is the percentages. Look at that percentage now. Percentage is like, for example, here's a very interesting one coming from this problem here. Cold water fish, such as salmon. So here is your salmon. Salmon contains 1.9% omega-3 fatty acids. So I'm just going to put it as fats by mass. So what does this mean? This means that 1.9 grams fats are present in 100 grams of salmon. This is what it means. So you see, the whole sentence has been presented in a very simple equality. Okay. Now you can write the conversion factor easily. 1.9 grams over 100 grams salmon, like total weight of the salmon fish. And there's 1.9 grams is the fats. Okay. Or 100 grams of salmon over 1.9 grams of fats. Okay. So this is another way, you know, you can convert these sentences into this thing. So there's plenty of you know, problems. Now what time is it? It is 4:11, you know, so I have to finish this thing, but it is not going to be finished because now I have to show you how to do these conversions. So let's do this way. If you guys, how many are there? 25 students are there. Yeah, a few of them told me that they're not coming. So I'll mark you guys present, all of you. So I'm thinking I should finish this because it's just 2-3 more problems. If you have to leave, you can leave. Because this is being recorded anyways. But if you have to stay, that is good. Okay, so if you could stay, that'll be great. All right, so let's finish this problem right here, page 45. Now we are looking at these conversions. Page 45. And this is a study check problem 2.9. All right, study check 2.9. So here you are given a total of 200. So write down all that is given to you. A total of 2500 milliliters boric acid. Okay, boric acid. Antiseptic solution is prepared from boric acid concentrate. How many quarts of boric acid? So in other words, how many quarts is that? 2500 milliliters of boric acid. So always, you know, there is always going to be some context in which we are showing these 1 minute. Concepts. Yeah, we have to do those. I think I missed those significant figures. Yeah, I missed the significant figure. Anyways, I have to do those also. Later on, I'll do that. Anyways, so let's do this. 2500 milliliters boric acid. Convert that to quarts. Okay. So we are going to now look at the tables. So that either the equalities are going to be given to you. Equalities, either you have to look at them in the tables, and this table is in the handout, or you can look at a table in the book, or you can do a Google search to look for the equality. And sometimes, that could be a little bit misleading, or we will be given to you. I'll give you in the question. Okay, so here we are basically looking at the units of milliliters and quarts. So relationship of them, is it already known or not? So we see that, let me see, milliliters and quarts is in the table. Yeah, so 1 liter, okay, here, 1 liter given is equal to 1.06 quarts. Okay, this is known. This is known. So there is no direct relationship between milliliters and quarts. So what are you going to do first? Convert milliliters to liters and then liters to quarts. So how do we do that? We know that 1 liter is equal to 1000 milliliters. Again, this is, coming from this story right here. We looked at the relationship between liters and milliliters. Or you guys can, you should just know this, that 1 liter is 1000 milliliters. Okay, so now we are going to write down first 2500 milliliter. First convert that to liters. So we know that 1 liter is equal to 1000 milliliter. Why did I do that? Because see, this equality can be made into 2 conversion factors, 1 liter over 1000 milliliters, or 1000 milliliters over 1 liter. And which one are we going to use? Because we need to convert milliliters to liters, so we are going to use this one. This liters is what we want. We want to get rid or remove the milliliters. That is why we use that one. Okay, and you can move forward with this here. Next thing is the question is actually asking us to find the quarts. So the quarts is going to be on the top, and that quart is 1.06 quarts over 1 liter. We want to get rid of the liters because the question final answer has to be for the quarts. That's what we need. So that is why. And where did we get this? This is right here. Again, the two conversion factors of it, and so we get that. Now we see that the milliliters and milliliters cancel out, and liters cancel out, and you're only left with the unit of quarts because that is what the question wants. Okay, so now you are going to take 2500 times 1 times 1.06 quarts over 1000 times 1, and what do you get here? What is the answer?
2.65 quarts, I believe.
2.65 quarts. Okay, so that's the answer. Okay, so this is the way you will do. So let us say do one simple one, simple example. Let us say you are given, so here is one problem where you are given, problem is that an individual is, the weight of an individual is 150 pounds. Okay, and the question is, how many grams is that? What is the weight in grams? So what we will do is look in the table. So go and look in the table. Now this table, I have also given some tables in the handout. In the handout, if you look at it, there are some tables on the equality that are given in the handout. If you look into my screen, my camera, these tables are given right here. All this has been explained. Okay, so use the tables in the handout, or you can use in the book. So we have to look for the equality, which is how much pounds and grams, the relationship between pounds and grams. So the pounds and grams, there is no direct, 1 pound, there it is. 1 pound, we know it's given is, from the book is, in the table in the book. And you're welcome to write these if you want to, on your own, with your own handwriting. So 454 grams is equal to 1 pound. Okay, so this is given. This is given. And the two conversion factors, as we talked about, 454 grams over 1 pound, or 1 pound over 454 grams. So two conversion factors. Now we are given, so write down what is given to you. We are given 150 pounds. And we want to convert that to grams. So we are going to use this conversion factor, because pounds is in the denominator and that is going to cancel the pounds out. So write down 150 pounds times 454 grams over 1 pound. And now you cancel these two out. So you are now left with 150 times 454 over 1. What do you get?
6,800, 68,100 grams.
100, like that? 68100
Grams.
grams.
Yeah, she's right.
Okay, good. So 68100,
Indeed.
and that is it's always write the units. So got that? So this will come through practice, and that's why I'm saying the best would be to start with the extra credits first, so that you'll never go wrong with that. Okay, next is when 2 or more conversion factors are given, and then after that I'm going to stop. When 2 or more conversion factors are given, and okay, here, page 47, and this is 2.11 study check. This is a study check. I will do all the study check problems. Study check. Okay, so here a bottle contains 120 milliliters of cough syrup. So write down here, one bottle. A bottle means 1 bottle. Contains means equal to 120 milliliters of cough syrup. Okay, cough syrup, and you don't have to write down like as far as it's something. Okay, 120 milliliters of cough syrup. Okay, next is if 1 teaspoon. So next write down here 1 teaspoon. 1 teaspoon equal to 5 ml, and this is given in parentheses. So this means that is given 4 times. 4 times. So that means 1 teaspoon. So 4 times means 5 ml is given like 1 time. 1 time. So 4 times would means 20 ml is given in 4 times. So anyways, it's given 4 times a day. So 4 times a day means in 1 time. So 4 times would mean 4 times would means 5 times 4. So that is 20 ml. And this 20 ml is given in 1 day. This is given in 1 day. This is what it means. How many days? So the question is now asking days. How many days will elapse before the refill is needed? So in other words, this 120 ml is going to last how many days? This is what it means. So basically, the entire sentence has been now converted to equalities. And we have extracted what information do we want from this. All right. Now, how would you do this? We have to start from somewhere. So we will start from like our main issue. Main issue here is what? Oh, main issue is 120 ml is going to last how many days? 120 ml is going to last how many days? So write down 120 ml and we need to convert milliliters to days. You look at that, milliliters to days. So 120 milliliters times, we need to get rid of the milliliters first. So, so we don't care about the bottle, but we look at the teaspoons. So convert the teaspoon. So 5 milliliters make 1 teaspoon. 5 milliliters and milliliters get cancelled. And we are given 4 teaspoons in 1 day. So 1 day we are given 4 teaspoons. So that converts the thing. So now if you milliliters and milliliters cancel out, teaspoons and teaspoons cancel out. So you are just left with the day now. So 120 times 1 divided by 5 times 4. In other words, 120 divided by 20. And this becomes how many days? 6 days.
6 days.
Yeah, very good. So, you know, this is how you are going to use these conversion factors. Just break it up into these equalities. Okay, let's look at one more example here. And then after that, this is the last one. Last one is page 47. Okay, page 47. And this is problem 2.12. Okay, here a person who exercises regularly has 16% body fat by mass. So just break this up right here before even reading any further. This means 16 grams of fat is present in 100 grams of the total mass of the body. Okay, so this is what it means. And the other conversion factor of this is 100 grams mass, like the total weight of the body, divided by 16 grams fat. So 2 conversion factors, 16 grams fat is equal to 100 grams mass. And these are the 2 conversion factors of this, 1 and 2. Okay, now next is, if this person weighs 155 pounds, what mass in kilograms? Mass, so this is the weight of this person. So what mass in kilograms? What mass in kilograms? What is the mass in kilograms of body fat? So if this person weighs 155, what is the mass? So in other words, kilograms, this is a little bit confusing here. What is the mass in kilograms of body fat? So how much, in other words, how much of the fat in grams is present in 155 pounds of the total body weight? So here's the good part about the percentages. Percentages is like kind of flexible. So if you use grams of fat, it will be grams of mass. If you use kilograms of fat, it will be kilograms of the mass. If it is pounds of fat, it would be pounds of the mass. So, you're flexible with that. But the only thing that is not flexible here is that we need to convert the pounds to grams, pounds to sorry, this is in kilograms. This is in kilograms. Fat in kilograms. Yeah. So we need to convert the pounds to kilograms and then go from there. Okay. So this also means that 16 kilograms of fat over 100 kilograms of the body mass, or 100 kilograms of the body mass over 16 kilograms of fat. This also means that 100 kilograms of the mass over 16 kilograms of fat. Okay, so this is with the percentages, it's like that. Okay, so anyways, we need to convert this pounds to kilograms first of all. And the relationship that is known from the table is 1 kilogram is equal to 2.20 pounds. Okay, 1 kilogram is 2.20 pounds. So this is known. So let's first convert 155 pounds into kilograms. So we know that 1 kilogram is equal to 2.20 pounds. Okay, so that converts the pounds to kilograms. Next, we need to find how much of the fat is present there. So we need to get rid of the kilograms. So 100 kilograms of, we need to get rid of this is the body mass. This is the mass. Okay. This will convert this into a mass of the body. Okay, so this is again mass of the body, and this is 16 kilograms of fat is present in 100 kilograms of the total body. So now you get rid of the pounds, get rid of the kilograms, and you are just left with the kilograms of fat. So 155 times 1 times 16 divided by 2.20 into 100. And you were going to get 11 kilograms of fat. Okay, so the same thing is for the beef also. I didn't do the study check on this one, but I did the worked example. But anyway, so this is the way you do that. So I'm going to stop here now, and whatever is left, there are a few things. I'm going to make a video on the significant figures, and then basically significant figures. That is the only thing that is left. So look for, I'm going to write it down here. I'm going to post the video. Just give me a day or two to do that. Okay, so look at the video for significant figures. Look at the video lecture on significant figures. And in a day or two, you will see this online. So where am I posting the recordings? This also is recorded. This lecture is recorded, and the PDF file of these lecture notes, you will get them in the module. So see them in the weeks. Like I said, you have to just go in the module to get whatever content you need. All right, guys, thank you so much for being patient. And I'm stopping the recording and marked everybody present here. So if you have any questions, you can stop. And, otherwise,